Picture this for a second. You're sitting in a classroom, or maybe a boardroom, and you're working through a really complex problem with your team. Only, there is an invisible teammate sitting right there with you. This teammate is a futuristic AI, and it's actively monitoring your group's collective brainwaves. The exact moment your team hits cognitive overload, when the coordination just becomes too much and the actual learning stops, this AI instantly steps in to help. Okay, let's dive into this. Because as wild as that sounds, the foundation for this technology isn't science fiction at all. It is a very real, very active area of study right now. Welcome to this explainer, where we're going to unpack a fascinating new scoping review that asks a pretty simple question. Where exactly is the mind-reading AI?
Right, so that question is really at the heart of what researchers call neuro-adaptive collaborative learning. And the tantalizing promise here is that the hardware and the software required for this straight-out-of-sci-fi concept, they actually already exist today. We've got the devices to read brainwaves, and we absolutely have artificial intelligence that can process complex data. But as the researchers behind this study found out, bringing these incredible technologies together to genuinely support a team's learning process is turning out to be one heck of a complex puzzle. So, to understand why this puzzle is so tough to solve, we need to look at the individual pieces first.
That brings us to Section 1, the building blocks, how to build a mind-reading tutor.
There are three core technologies you need to make this futuristic classroom happen. The first building block is hyperscanning. This is your hardware. And honestly, this is a brilliant example of the leap from individual neuroscience to social neuroscience. Basically, hyperscanning involves concurrent neuroimaging, so using caps fitted with sensors like EEG or fNIRS on multiple interacting brains all at the exact same time. It makes it possible to literally watch a team's shared brain activity, their neural synchrony, happening in real time while they are genuinely collaborating. It's not just one isolated brain in a scanner anymore. It's about seeing how our brains sync up when we work together.
Okay, moving on to the second block, agentic AI. Now, this is very different from the generative AI tools we're all using every day. It's not a standard chatbot where you type in a prompt and wait for an answer. Agentic AI is a neuro-adaptive system that actually takes the initiative. It doesn't wait around for you to ask for help. It acts immediately as a socio-cognitive teammate based on those real-time neural signals it's picking up. It senses that you're struggling, and boom, it proactively steps in to tweak the task or offer a hint. And the final building block is the specific problem this AI is actually trying to solve: collaborative cognitive load. Look, whenever you work in a team, there's a mental tax. Distributing knowledge and just coordinating with other humans eats up incredibly valuable working memory resources. If that transactional cost ends up outweighing the benefits of the teamwork, the learning process just completely breaks down. Regulating that shared cognitive load is exactly what the agentic AI and the hyperscanning hardware are teaming up to manage.
Which leads us straight into Section 2, the tech mystery, searching for the missing link. So, we've got the hardware to read the brains, the AI software to act on the data, and the psychological construct we're trying to manage. Now for the mystery. Researchers recently ran a massive scoping review of the Scopus Scientific database, targeting peer-reviewed literature published from 2022 to May 2026. Their mission was to find the exact intersection where these three blocks finally converge in collaborative learning. They used a rigorous methodology called a PRISMA scoping review. They started out by screening 551 potential scientific records. Through a really strict inclusion process, making sure the studies actually involve collaborative learning and not just individuals, they whittled hundreds of papers down to 35 sought for retrieval. And ultimately, they landed on just 10 highly eligible studies that contained all the right ingredients.
Now, these 10 studies represented the absolute bleeding edge of educational neuroscience and collaborative learning. They had the right context, the right tools, and the right focus on cognitive load. So here is the multi-million-dollar question. Out of these 10 frontier studies, how many of them successfully integrated an agentic AI with real-time neural data to actually manage a team's cognitive load? Zero. Absolutely zero. Despite the fact that the hardware and the software both exist right now, not a single one of these cutting-edge studies had an agentic system actually act on the decoded cognitive load of a team. When the researchers charted out the AI integration across these 10 studies, exactly where the tech is falling short became glaringly obvious. Neural decoding itself, highly active. 8 out of the 10 studies successfully used EEG or fNIRS to measure the brain. But then you look at the AI side, wow, 6 studies used no AI at all. 2 used scripted, rule-based agents that completely ignored the neural data. 1 used machine learning offline, meaning it just analyzed the data after everyone had already gone home.
and one used a generative AI tool, but just as a basic task aid. That specific category, for a closed-loop agentic AI, where the system actively reads the brain and acts in real time, that category is completely 100% absent.
When they plotted this all out on an evidence gap map, it didn't look like your typical messy field of emerging research. No, it showed a precise, well-defined absence. There is literally an empty cell, a gaping hole where the convergence of these mature technologies should be happening. The components exist separately, sure. They're even being used in adjacent domains, but they simply have not been brought together for collaborative cognitive load in education.
And that brings us to Section 3, an unsettled construct. Let's look at the real culprit behind this missing tech.
So why is this cell totally empty? Why haven't we built this yet? Well, the zero we just looked at isn't a failure of hardware or software. The real culprit here is a massive, incredibly human definitional issue. When you actually break down the data, you see that across those 10 studies, the core concept of collaborative cognitive load is operationalized in 3 totally incompatible ways. It's wonderfully ironic, isn't it? We have this wildly advanced artificial intelligence, but it is entirely grounded because human scientists can't agree on a definition. 4 studies measured the load neurally, looking at inner brain synchrony. 5 measured it subjectively, just asking participants to fill out self-reported surveys like the NASA TLX scale. And 1 study just used it theoretically, framing the concept without actually measuring it directly at all.
This creates a fundamental disconnect. On one hand, you have a neural team signal, which is an intrinsic, real-time measurement of the whole group working together. On the other hand, you have a subjective individual survey, which is just an aggregation of what individuals say they felt after the fact. Think of the AI like a conductor trying to lead an orchestra. The conductor is ready to go, baton in hand, but half the orchestra is playing off a Mozart score, and the other half is reading sheet music for a Metallica song. The AI cannot step in and help if it doesn't know which signal it's supposed to follow.
And this is the core obstacle. Because there is no shared measurement standard, there's zero convergent validity tying these metrics together. Think about that. Not a single study tried to map the neural data directly to the subjective survey data within the same task to see if they even align. Because of this definitional ambiguity scattered across all these different disciplines, the AI literally has no stable, agreed-upon signal to track. You just cannot program an AI to fix a problem if you haven't clearly defined what that problem looks like in the data.
As the researchers so perfectly summarize it in their review, the contribution is therefore less the empty cell than its explanation. Not a missing technology, but an unsettled construct. Before we can build this incredible mind-reading classroom of the future, we have to fix our own definitions first. The tech is literally just waiting on us.
Let's look at how we do that in Section 4, the future of mind reading, fixing the roadmap.
So how do we actually fix it? What is the roadmap to finally get us to that closed-loop neuroadaptive system? Well, the scoping review doesn't just point out the flaws, it lays out a highly concrete, actionable research agenda. First and foremost, researchers absolutely must establish convergent validity. We need studies that record both the neural indices and the subjective self-reports within the exact same collaborative task, proving once and for all how these measurements relate to each other. Once we fix that signal, step 2 is to design feasibility tests for actual real-time closed-loop systems in education. Basically, plug the AI into the hyperscanner and let it run. And finally, we need to expand the scope. Right now, most of this research is just 2 people, small laboratory dyads. We have to scale this up to real, cross-disciplinary, multi-member classrooms.
But as we march toward this roadmap, there is a massive ethical implication that we simply cannot ignore. Because the technology already exists in adjacent fields, this convergence is coming. It's not an if, it's a when. And that means we urgently need to talk about neural data privacy. We are talking about educational institutions collecting real-time, unfiltered brainwave data directly from students.
The researchers emphasize that governance has to be established proactively, not scrambled together after the fact. We have to anticipate the sheer scale of this kind of data collection. We absolutely must advance the global neuro rights agenda, making sure that human cognitive liberty is protected. And critically, our educational frameworks need to implement guidelines like UNESCO's upcoming 2025 standard on the ethics of neurotechnology before these AI systems are deployed in our schools and businesses. The components are sitting right there on the table. The hyperscanners are active. The agentic AI is getting smarter every single day, and the moment we agree on how to actually measure collaborative cognitive load, that glaring gap in the map is going to be filled. The closed-loop system is going to become a reality. So the ultimate question left for us to ponder isn't whether this technology is possible, but rather, when the AI is finally ready to read your team's mind to help you learn, are you going to be ready to let it?